Hi Chem Gang, it is October the 11th, 2018, Thursday, and tonight was our live Skype session. Now unfortunately, the recording for tonight didn't work properly, so what I'm going to do is do a recording after the session talking about a few things that came up in session. So tonight there weren't a lot of people in session, so not a whole lot of questions, but it was wonderful to see the students that were able to come and ask their questions. If you missed tonight's session and you have some questions that you would like me to go over, please let me know, preferably through the discussion group so that we can share your question and the answer with everyone, but also feel free to send me an email or text my cell. So feel free to do that. So one of the things that we talked about was the periodic table that you will use during the test. And I have it up here. This is the periodic table that you're going to use. One of the things that we noticed about the periodic table tonight is that something like the aluminum element is bordering on the metalloids, and the transition metals are here in blue. Our alkali and alkaline earth metals are here in group 1 and group 2. So we know that from group 1 all the way over to group 12 we have our metals, and beyond that it can be difficult to figure out if we're dealing with a metal or a non-metal because the metalloids aren't really shown very well here. It's a weakness of the periodic table in the test. So what I'm going to say to you is that in the test we're going to be very specific when we ask you a question to let you know whether you're dealing with a metal or a non-metal. So you'll have that. If there's a question that you feel was ambiguous on your test, please just let me know about it, and I can override any mark that's in the test if it's not fair, and then I'm happy to change that for the next term as well. So we both benefit when you are the squeaky wheel. And if there's something that comes up that you weren't given the proper resources in order to answer the questions, please let me know. It means that you'll get an extra point, and it will also mean that I can improve the course. So just be aware that yes, the metalloids aren't really well identified here in the periodic table, but hopefully that won't mix you up because we're going to be very, very specific in the test of whether you're dealing with a metal or not. A couple of other things with the periodic table. We talked about the difference between, and I'm going to bring it up here so that I can write on it. Oop, that's not the one I wanted. That's another one. Print screen. I'm going to bring it into Paint so you can see it. There we go. That's better. So I can write on it. So some things that you need to know about the periodic table is how to know whether an atom will have a positive charge or a negative charge. So we know that group 1 atoms have a charge of +1, and we know that the group 2 atoms have a charge of +2, which means that in order to become stable, they would rather lose an electron and become more positive in order to be stable. So we know that hydrogen, the group 1s have just one valence electron in their outermost shell, and it's easier for those atoms to lose those electrons in order to be stable. So that's why they are +1. And group 2 atoms have 2 electrons in their outermost shell, and it's easier for them to lose 2 electrons to become more positive, and so that's why they're +1 and +2. We skip over the transition metals because depending on what non-metal that they combine with, their charges can differ. Their charges are always going to be positive as well, but they might be +1, they might be +2, or they might be +3, which means that they lose anywhere between 1 and 3 electrons when they're bonding with a metal, and it varies depending on which metal or non-metal, sorry, that they bond with. So the transition metals vary, so you don't have to worry about those until we get into bonding with transition metals, and then it's something that you can worry about. But for now, you definitely know that group 1s have a positive 1 charge, group 2s have a positive 2 charge. And I messed it up over here because of this box, which I can move. So our last group, which is group 18, is ennoble gases, and we know that their net charge is 0, and that's because their outer shells, their valence shell, has a full 8 electrons, and it's going to be the most stable, and so it has no charge. But group 17, which are the halogens, which is down here, they have 7 valence electrons, which means they need to gain an electron in order to have a full valence shell. So it's going to be -1 starting with the group 17, -2 for all of the atoms in group 16, and -3 for all the atoms in group 14, and then -4 for everything in group 14. So if you want to, on your scrap paper, when you get in, what I would do is I would say group 1, group 2, and then over here I'd go group 18, 17, 16, and 15, just on a piece of blank paper, and I go +1, +2, and then I would say no charge, -1, -2, -3, and -4. This is going to be my little hint for when I'm working with ions and ionic compounds to help me remember what the charges are on my groups. And as long as I have that at the top of my scrap paper, then that's going to be great when I get into the test. And if I forget it because I'm stressed in the test, I can just go back to my scrap paper that I put down at the very beginning of the test and just refer back to this. I could even put a little curly thing and say in the middle is my transition metals, and they're going to be either a +1, +2, or a +3. So feel free when you get into a test to just jot down some things that are going to be helpful for you as you are working on the test. So that's about what the ionic charges are for the atoms on the periodic table. The other thing I was going to show is, no, I'll go back to that one. Print screen again. The other thing we talked about is how you use the, get my pen here, how you use the atomic number here we go, atomic number and the atomic mass to figure out the number of protons, the number of electrons, and the number of neutrons for each of these elements. The atomic number is always going to be the number of protons that you have, and the number of protons never changes. So if you have an atom that has 4 protons, it's always going to be beryllium. If you have an atom that's 30 protons, it's always going to be zinc. So the number of protons is always going to be the same as the atomic number. That doesn't change. So for beryllium here, my number of protons is going to be 4. My number of electrons, if the atom has no charge, it's not charged, it's also going to be the same as the atomic number. So if the atomic number is 4, then we'll have 4 protons and 4 electrons. Now if beryllium becomes an ion and it becomes and it has a charge of +2, that means that it's going to lose 2 electrons. You're always going to have 4 protons, but it's going to lose 2 electrons. So the number of protons for a +2 ion of beryllium, you'll have 4 protons, but instead of having 4 electrons, you're going to have 2 less, because you're going to have 2 more protons than electrons. That's what that +2 means. 2 more protons than electrons, and if you can't change your protons, then you have to change your electrons. So proton number doesn't change. Electron will change if you're dealing with a charge. And all of that is figured out using the atomic number. Atomic mass we use to figure out the number of neutrons, and the number of neutrons is going to be the atomic mass subtract the number of protons, and then we round it. So 9.01 minus 4 gives us around 5. So the number of neutrons in a stable beryllium atom is going to be 5 neutrons. And that's just taken from the atomic mass. The reason why the atomic mass number is a decimal is because in nature, beryllium sometimes has a mass of 9, sometimes it will have a mass of 10, sometimes it might have a mass of 8. And the difference between beryllium 9 isotope, beryllium 10 isotope, beryllium 8 isotope is that the number of neutrons between each is different, but they'll always have the same number of protons. So the number of protons for beryllium 9 isotope will remain as 4. The number of protons for beryllium 10 is going to be 4. The number of protons for beryllium 8 is still going to be 4. The atomic number for an atom doesn't change no matter whether it's an isotope or it's an ion. But what does change for each of these isotopes is the number of neutrons. What we're going to do is take the isotope number of 9, subtract the number of protons, and we're going to get 5 for beryllium isotope number 9. For beryllium isotope number 10, the number of neutrons is going to be 6. And for beryllium 8, the number of neutrons is going to be 4. So if you were to get a group of beryllium atoms, you would see in the mix that some would have an atomic mass of 9, some would have an atomic mass of 8, some would have an atomic mass of 10, and all together their average is going to make this 9.01218. And that's why our atomic masses don't round off completely, because of the isotopes, the different atoms with a different amount of neutrons. The neutron number doesn't change the properties of the atom, only the proton number does. So all these beryllium isotopes have the same properties, it's just that their masses are a little bit different. So you will see a question on the test where they'll give you the isotope number and they'll ask you how many protons it has, and then you have to figure out the number of neutrons. So it's good to know the difference between all of these. So that was the big thing we talked about in tonight's Skype session. Again, thank you for watching the video, and thanks to those of you that came out tonight. If you have any questions that weren't addressed in this video, as you are studying for your proctored test next week, please post to the Unit 2 discussion group, or give me a text or an email, and I'll be happy to answer your questions. So I hope your studying is going well. Still lots of time to get through these questions, and I look forward to your questions on the discussion. So have a great night, and thanks for watching. Bye for now.